Okay.
I'm trying to record this so see what happens today. Oh yeah. Okay. Factoring. We're gonna do worksheets for like the next 2 weeks too, so you won't need your textbooks for the next 2 weeks. That is excellent, right?
Yes.
Factoring quadratic equations. The types. Well, actually, we're factoring just expressions today because there won't be any equal signs. We'll do equations on Wednesday. There'll be 2 types of expressions that we factor. There's binomials and trinomials. Prefix bi means how many? 2, and the prefix tri means 3. Okay, so a binomial is a polynomial of 2 terms, and then a trinomial is a polynomial of 3 terms. So those are the 2 different types of expressions that we will factor today. Before we factor, we're going to review FOILing. And factoring and FOILing are like, I don't know, say inverses of each other, but they're opposites. And you do one, and then you do the other one. FOILing acronym, that stands for your first terms, and then you would do your outside terms, and then it tells you multiply your inside terms, and then finally the last terms. I'm not sure how your teacher taught you last year with monkeys and rainbows and clouds or whatever for your FOILing. I'm just going to go based off of what it says. So for FOILing, multiply your first term. So we're going to take x times x, and what do we get?
X squared.
X squared, good. X times x will give me x squared. Outside term, so that's x times negative 3. Would be negative 3x. The I stands for inside terms, so that's 14 times x, which would be positive 14x. And then the L is your last terms, so that's 14 times negative 3, and that would be negative 42. Make sure you simplify this. Your inside terms should always combine. Negative 3x and positive 14x makes how many x's? 11x. So our final answer would be x squared plus 11x minus 42. Okay, try number 2 on your own. By FOILing.
What?
Happy Monday. F for my first term, 2x times 3x. 6x squared. 2 times 3 is 6. X times x is x squared. Bless you. Oh, the outside terms, 2x and negative 4. Would be negative 8x. I, the inside term, negative 3 times 3x would give us negative 9x. And bless you, the last terms, negative 3 times negative 4, what? Positive 12. Combine your insides, so you should get 6x squared minus 17x plus 12 for your final answer. And the third one, where we're practicing FOILing. First terms, x times x, x squared. Outside terms, x times 4.
4x.
Inside terms, negative 4 and x. And then your last terms are negative 4 and 4. Would give us negative 16. On the inside, 4x and negative 4x. What happens to them? So then we're left with x squared minus 16. Okay. What we're going to do today is go in reverse. We're going to start with something like 6x squared minus 17x plus 12, and then break it into the 2 parentheses. Algebra. The greatest thing about algebra is that you can check your answers. To check factoring, what you do is you FOIL. So that's why we practiced our FOILing. To check your final factored form, you want to FOIL it back out. By definition there, factoring is rewriting an expression as the product of its factors. Rewriting an expression as the product of its factors. goes with product? Multiplication. So if I have the expression 21, I can rewrite this as 3 times 7. That's factoring. Rewriting it as a product of its factors. I could rewrite it as 1 times 21. That's another way to factor 21 out. If I had 4t, just 4t. Then if I wanted to factor that, it'd be 4 times t. That's one way you could do it. I could factor this as 2t times 2. Okay, so factoring, you're just rewriting it as multiplication problem. A GCF, the greatest common factor of an expression, is the common factor of each term of the expression that has the greatest coefficient and the greatest exponent. The GCF of an expression has to contain the greatest coefficient and the greatest exponent. Coefficient, that's that number out in front of the variable. Hopefully you guys remember what the exponent is. Start basic here. If I want to find the greatest common factor of 21 and 56, I'm looking for the biggest number that can evenly go into both of them. Hannah? 7. Good. The greatest number that can go into both of those would be 7. 21xy and 84y. So now I've got numbers and variables. So break it apart. First, look for the greatest common factor of 21 and 84. 21, good. 21 can go into 84 how many times? 4, okay. So I know my greatest coefficient would be 21. Now looking at the variables. The first term has an x, but the second one doesn't. So would x be a common factor? No. A y and a y, would that be a common factor? So then our GCF would be 21y. It's the biggest number that can evenly go into both of those. Okay, so if I give you the terms 3x squared y and 12xy squared, go in pieces. Coefficient 3 and 12, what's our GCF for those? 3. It's the biggest number that goes into both of them. X squared and x. X, right? Because x squared means there's really how many x's over there? 2. And then I have 1 over here, so the most I can take away is 1x. And then y and y squared, so what's the most number of y's I can take away? Just 1, because there's 1 over here and then there's 2. So our GCF for those two terms would be 3xy. Why do I have to look for GCFs? Because that's the first step of factoring. You always have to factor out what's common before you do any of the parentheses stuff. You should have all these rules typed out for you. So rule number 1, factor out all the common factors. You're looking for the GCF first. It's the rule that most students forget. So that is the rule we need to remember. That's your first step. After you get your GCF out, then you either look to see if it's a binomial or a trinomial. Binomial, 2 terms. It could be what's called a difference of squares. Math operation that goes with the word difference is what? Subtraction, minus, yeah. Okay, so a difference of squares will be a binomial where there's a subtraction symbol. Squares means that each term has to be a perfect square. So what would be the square root of x squared? X, my bad. What would be the square root of 16? 4. So a difference of squares, when you factor it, it's always the square root of the first term, and then it would be the square root of the second term, and then plus, minus. The more you do these, the more you'll pick up at them, and the easier they will get. You'll be able to recognize difference of squares right away. Binomials, they only come as binomials. Subtraction, there's your difference. Is y squared a perfect square? How about 144? Yeah, so when I go to factor this, the first terms are the square root of y squared. What's the square root of y squared? Y. The second terms are the square root of 144. And then it's always a plus and a minus, because that gets rid of the middle term. A positive 12y and a negative 12y cancel out. So if it's a binomial, check to see if it's a difference of squares. It won't always be, but check that. If it's not a binomial and it's a trinomial, then you're going to factor by trial and error. I do mostly trial and error, but there are the sign rules there listed as well that might be helpful. If your last term is positive, so if you have a trinomial, ax squared plus bx plus c, this last term plus something, then your signs will be the same. They will either be plus, plus, or minus, minus. So if your last term is positive, just the number, then you have the same sign. If your last term is negative, say plus bx minus c. So if it's minus a number, then you have one of each. You have a plus and a minus. Okay, so if you kind of get stuck with the trial and error, maybe double check your sign rules. Oh, they're both positive, so I know they both have to be positive here. But don't always be dependent on those either. After you think you've had it factored into the two parentheses, then you always want to check by foiling them. Algebra, greatest thing about algebra is you can check your answers. And you can still check them here even though we're not solving for a value. We're going to check by foiling. Okay, we're going to run through quite a few examples today, so you have a little bit of something for your worksheet, a little bit of everything. Your first one's there. 6x squared plus 6x plus 30. First step of factoring is to what? GCF, look for a greatest common factor. So between 6x squared, 6x, and 30, good, Remy, 6. They all have a 6 in common. Factor that out, so put it out in front, and then draw your parentheses. Factoring out is kind of like dividing. So 6 times what would give me that 6x squared? X squared. I would have left an x squared. 6 times what is 6x? X. So then plus x. And 6 times what would have given me that 30? 5. So when you factor your 6 out, what's left is x squared plus x plus 5. Keep going now. Looking at the inside, so you just keep your 6 out front. If you want to go with your sign rules, you can. Sometimes I mention them, sometimes I don't, because usually I don't. If your last term is positive, the numerical value, then they're going to be the same sign. That's based off of whatever the first sign was. So these are both going to be a plus. So I know for sure I can just put a plus plus in there. This value times this value has to give me x squared. X and x. Then the second value times that fourth value has to give me 5. You will only use whole numbers today. 1 and 5. Then the last thing we have to do is check by foiling. You don't have to do the first and the last terms. You always just need to do the outsides and the insides. So when I check my outside, x times 5, insides 1 times x, give me 1x. These two are supposed to make x. Is x and 5x ever going to give me 1x? No. If I'm using only whole numbers, is there anything else that multiplies to 5? Yeah, I could do 5 and 1, but is that going to change here? Okay, so what that means is that this is the best we can do. Just taking out the 6. That's all I can do to factor that. The more you do these, the easier they'll be, and you'll see that you couldn't have gone any further. Beginning, we just have to trial and error it out. Alright, B, 20x cubed y minus 25x squared y cubed. Gotta look for GCF. M, between 20 and 25, what's the biggest number that goes into those two coefficients? 5, right? Okay. I'm just gonna go bit by bit. Then I have x cubed and x squared. So what's the most number of x's I can take from each? X squared. Y and y cubed. So what's the most number of y's I can take away? Just one y. Parentheses. So I'm factoring that out. It's like dividing. So when I go to see what's left over, you have to think multiplication. 5 times what would have given me 20? 4. X squared times what would have been x cubed? X. And y times 1 is y, right? I took that one y away. So then that's the first term that's left. Minus, now we're moving to the second one. 5 times what would have been the 25? 5. X squared times, well, 1 is my x squared. I took all of those away. Y times what is y cubed? Y squared. I would have 2 y's left over there. Okay, look on the inside. Binomial or trinomial? Binomial. Sum or difference? Difference. So I have to check if these are perfect squares. Is 4x a perfect square? 4 is, right? But x isn't. So since 4x is not a perfect square, this is not a difference of squares, and we would just be done there. Alright. Next two. Z squared minus 49. Is there a GCF? No. Binomial or trinomial? Binomial. Sum or difference? Difference. Okay. Is z squared a perfect square?
Yes.
49.
Yes.
Okay, this is what's called a difference of squares. This will be factorable. The square root of z squared is? The square root of 49 is?
7.
And then your signs, 1's plus, 1's minus. Can I do anything else on the inside of those parentheses? There's no more factoring I can do, so that's my factored form of that difference of squares. D. 16r to the 4th minus 625. GCF there? Probably not, because 2 won't go into 625, and 5's not going to go into 16. Wait, stop. Hammer time. There you go. Okay, so there's no GCF. It's a difference. Is 16 a perfect square? Yeah. R to the 4th? Any even exponent is a perfect square. 625?
Yes.
Yeah, it is. Anyone know the square root?
25.
It'd be 25, yep. That's 125. So, this is a difference of squares. Square root of 16r to the 4th. Okay, what's square root of 16? 4. Square root of r to the 4th? R squared. Good. So 4r squared and 4r squared. And then Kyla said the square root of 625 is 25. You might need to use a calculator to help you with that one. 1's plus, 1's minus. Nope, it doesn't matter where you put your plus or minus. I usually just tend to do plus first. Can I do anything else on the insides of those? You sure can. The first one stays 4r squared plus 25. The second set of parentheses, it's a binomial that has a difference. 4r squared, is that a perfect square? Is 25 a perfect square? So I can actually break this set of parentheses down into 2 more. You have to, the positive one I won't be able to break down, the negative one I do. Square root of 4r squared. 2r. Square root of 25.
5.
And then 1's plus and 1's minus. 2r plus 5, can't do anything there. 2r minus 5, well, those aren't perfect squares, so this, now we are done. That's the whole thing factored.
Why can't you do 4r squared plus 25 would be just 2r plus 5 and plus 5?
Because then it doesn't cancel out the middle term. A binomial can only be broken down if it's a difference. There's subtraction in there. Okay, flip it over. Well, I mean, not necessarily. If you're getting them wrong because you're not checking, then it probably won't make it.
You have to break it down if we can. Like, say that one was on the quiz and we didn't break it down to 2r plus 5 and 2r minus 5.
Yeah, you lose a point for not factoring it all. Alright, top one, what letter are we on? E? GCF of 4x squared minus 20x plus 25. There isn't one. Okay? So then we're going to go right to our parentheses. If the last term is positive, will the signs be different or the same? Same. And it's going to match what our first sign was. So I know these are both going to be minus minus. So you could put them in there if you wanted to. Something times something has to give us 4x squared. You want to do 2x and 2x? Okay, or we could have done 4x and x. Yeah, that's the trial and the error part. Like I said, the more you do it, you'll be able to see in your head what works and doesn't, but trial and error. The second term there times the fourth term has to give me 25. 5 and 5. Check by foiling the outsides and the insides. So my outside terms, 2x times negative 5. Negative 10x. My insides, negative 5 times 2x. Well, negative 10x and negative 10x give me this negative 20x I'm looking for. Okay. Can I do anything else to 2x minus 5? No, there's no squares there, so I can't do anything else. So there's our answer. Next one over, 2x squared plus 3x minus 20. GCF, do I have one? Alright. My signs, will they be the same or different? Good, they'll be different because the third term there is negative. When they're different, I don't tend to put them in. Because sometimes they switch around, so I just usually leave them out when they're going to be different, but it's totally up to you. My first two terms have to multiply to give me 2x squared. 2x and x, that's the only thing I've got there. Then the other two have to multiply to make 20. 5 and 4? Okay. Check by foiling. Outside terms, 2x times 4. 8x. Inside terms, 5 times x. Can I add and subtract or subtract those two values to make 3x? What has to be subtracted?
Negative 5.
Yeah, I gotta do minus 5. So if I want my 5 to be negative, then this needs to say 2x minus 5 times the quantity x plus 4. Can I do anything else on the insides of those two? 2x minus 5? No, because there's no squares. And if it's a plus sign, usually not. So we're done there. Okay. X squared minus 22x plus 72. My signs different or same? The same, because the last term is positive, so that means they're going to be the same sign, and they're both going to be what in this case? Negative. When they're the same, then I don't mind putting them in right away, because it's not going to change anything. When they're different, I don't like to put them in right away. Something times something, that will give me x squared. First terms will be x and x. Then the last ones have to multiply to 72. This is if you're really good at math, like multiplication facts, or if you know how to use calculator. Sometimes it's beneficial to list them, so you know what you've used and what you haven't used. Six has got to go in there 12 times. I think those are all your whole number factors of 72. they have to both subtract to make what value? 22. So, which two numbers are going to subtract to make 22? 4 and 18, right? So then x minus 4, x minus 18. That's another way you can kind of do it without having to do your outsides and your insides. That only works, though, if you have no coefficient way out in front. If you have a coefficient out in front, then you have to use your outside and inside terms. Alright. Next guy. 4x squared minus 17x plus 18. Is there a GCF? Nope. My signs, same or different? Same, they're both going to be what? Negative. Okay, so we could put those in right away if you want to. Something times something that will give me 4x squared. 2 x's? Or 2x and 2x, okay? And then we need to make 18 when I multiply them. I can use 1 and 18, or 2 and 9, or 3 and 6. Those would be my whole number factors. What are we going to try? 3 and 6? Okay, it doesn't really matter. This is kind of the trial and error part. Outsides, 2 times negative 6, negative 12x. Negative 3 times 2 on the insides. Negative 6 and negative 12. Does that make negative 17? Ooh, we're so close though. Okay. Would it matter if I switch my 6 and 3 around here? No, because I'm multiplying by 2. You want to try 1 and 18? Outsides, 2 times negative 18. Insides, 1 and 2, or negative 1 and 2, sorry. Is that going to make 17? Guess we could try 2 and 9 then, since we have it. So my outsides, 2x and negative 2, negative 4x. Insides, negative 9 and 2x make negative 18x. Does that get me to 17? I've gone past it. Nothing else multiplies to 16 or 18, that's a whole number. So what can I switch around for you?
Have 4x and x instead of 2 x's.
Good. The other thing I need to try now is changing my first terms. 2 times 2 makes 4, but so does 4 times 1. So if all the back terms don't work, then you might have to go back through and check your first terms. I know it's still going to be minus minus. 1 and 18, 3 and 6, 2 and 9.
2 and 9.
Try 2 and 9. Outsides, 4 and 9, or 4 and negative 9.
Switch them around.
What? This would make negative 36x, and this would make negative 2. That's too much, right? Okay. If I flip them around, by doing 9 first and then 2, my outside terms, 4 times negative 2, make negative 8x. My inside terms, negative 9 times x would make negative 9x. Negative 9 and negative 8, is that negative 17? Alright, there it is. The more you do them, you'll be able to see it quicker. We just have to keep working through them. Okay. We have 4 left, because we're not doing the very last one. C squared plus 16CD plus 48D squared. Signs, same or different? Same, they're both going to be, okay. Since I this is called your A term, the number way out in front of the square term, then these are usually a little bit easier if your A term is 1. I can list factors of 48 and figure out which ones are going to add up to make 16. So we've got 1 and 48. Would those add to 16? 2 and 24. 3 and 16. 4 and 12.
4 and 12.
Yeah, 4 and 12. So I know those are going to be the terms I want at the end. So my first terms, C and C. And then 4D, because there's a D there, times 12D. That's how I get that 48D squared, is by taking the D's on the other terms. And if you look for your outside insides, C times 12D is 12CD. And 4D times C is 4CD. So that's how they make that 16CD in the middle. So make sure you pay attention to the variables. Okay, y squared plus 14y plus 40. Bless you. GCF. Anyone? Or does it have one? No? Okay. If you want to check your sign rules, are your signs going to be the same or different? Same, so they're both going to be positive. That A term, the number in front of the squared, is 1. So listing your factors here might be a quicker way than guessing and checking. Factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. Since the A term is 1, then I'm just looking for the numbers that will add to give me 14. 4 and 10. So then y plus 4, y plus 10. Would it be wrong if you wrote y plus 10 times y plus 4? Okay, good. No smiles. A squared minus 13a minus 30. Any GCFs here? No. Signs different or the same? Different. They gotta be different since your last term is negative. When they're different, I don't like to put them in. Something times something that will give me a squared. A and A. 30. 1 and 30. 2 and 15. 3 and 10. Oops. 5 and 6. They have to make 13. There's two possibilities here, right? Because 3 and 10 make 13, and so do 15 and 2. If I want it to be negative 13, and I want to use 3 and 10, wouldn't they both have to be negative terms? Did we say the signs were both going to be negative? No. So then I know that 3 and 10 won't work, because I have to have a positive and a negative value. If I want to make it negative 13, do I want the 2 negative or positive? Positive. I would need a plus 2 and a minus 15. So that way when you check it, your outside terms would give you negative 15a, and your inside terms would give you positive 2a, which gives you that negative 13a in the middle. Okay, trial and error. Don't get it the first time, that's fine. Go back and do it again. Last one. X squared plus 4kx minus 12k squared. So you're going to have two variables in this one. Do I have any GCFs? No. What about my signs? Same or different? They're going to be different. I'm not going to put them in right away. I know the first ones have to be x and x. 12. 1 and 12. 2 and 6. 3 and 4. Have to combine to make 4. 2 and 6. So one's going to be 2k, the other one will be 6k, so then I get that k squared. If I check 6kx, and my insides give me 2kx, if I want to make it positive 4, do I want to subtract 2 or subtract 6? 2. So then it should be x minus 2k, and then x plus 6k. Question. Trial and error. The more you do it, the better we'll get. So we're going to spend a couple days on this.